And I believe we are now live.
Awesome.
Those that are that may be watching later. This is Polygon Issuance number 54. This is on Friday, April 10th, 2015. And for those that may wonder, yesterday there was an event that occurred. And on our show later on, we're going to talk about an event that occurred 50 years ago. However, we're probably going to talk about the event yesterday for a little bit because it is current and people are talking about it. About the tornadoes that were in Iowa and especially in Illinois yesterday, and seemingly missing our guest who was thinking he was going to be having to stay up all night in northern Indiana, or Michiana as it's known over there. So they had the preliminary report of the tornado that went the northwest side of Rochelle and hit Fairdale, which is southeast of Rockford. It was a preliminary EF4, half-mile wide. They don't know how long it was. From what I could gather, it's probably going to be at least 50 to 60 plus miles. And it was the EF4, and they don't know when it started. They don't know where it started. But from a satellite image that I was seeing today on Twitter, they pretty much can guess where it probably started to a point.
Yeah, the reports were coming in somewhere around Rochelle, which anywhere south of Rochelle is pretty open.
Yeah.
But then it started getting into actually populated areas.
Yeah. So, and then that was the tornado of the day. And then the tornadoes in Iowa that I was covering on our network. Oops, some stuff's falling on me. We had two EF1s in Iowa, and then we had another EF1 in western Illinois from the same storm. One was 100 yards wide, one was 75 yards wide. The first one went, oh goodness, I think 15 miles or 20. The second one went 13 or something. I have it offhand because I don't have it on me right now. And the third one, which was in Illinois, went 7 miles. So that was the first tornadoes of the year in Iowa. We had our first tornado warning in Iowa yesterday on April 9th. So pretty much, and also, I'll mention this too because our people in western Iowa would hate to be left out. They had a snowstorm yesterday.
I like to be all-inclusive with this weather. It's almost as good as there was the historic one that happened in Wisconsin where there was a tornado outbreak, and then it did actually blizzard in like the same day or same 24-hour period.
Yeah.
I'm glad it wasn't quite that bad, but still, even today with the wind and everything like that, didn't help recovery efforts at all.
Yeah. I mean, the Weather Service in Des Moines had a funny image earlier today, which I retweeted, where it said the weather in Iowa on Thursday, April 9th, and they had pictures of hail, tornado damage, flooding, and a snowstorm. So Iowa gets it all anymore. So and it's like, well, it's April. We can have a snowstorm. We can have tornadoes. We can have them all in the same day, which we did, just not in the same place.
Yeah.
So that was pretty much the current weather, and now it's going to get. It was windy today. Fairly windy today. There was a little bit of activity. Most of the severe weather was along the East Coast, down in the South. Might get active toward the end of the weekend again. We'll wait and see about that. But that's not what we're about to talk about. We're about to talk about an event that occurred 50 years ago tomorrow, which is known as Palm Sunday, 1965. Most people nowadays would know of Palm Sunday. If you mention a tornado outbreak, they would mention the Palm Sunday 1994 outbreak, which occurred in March of 1994. That was in the South. What people wouldn't probably remember too much is Palm Sunday 1965, which was not technically the first tornado outbreak that occurred on Palm Sunday, because there was a tornado outbreak on Palm Sunday 1920, which people don't remember anymore because not many people, if any, are alive from that time. But we're going to talk about the one in 1965 that was fairly deadly, killed 270 some people. I'm getting reports that it was either 260, 270, 271. It's somewhere in that realm. Many of them where our guest is, which is Tom Coombs. I think that's how it's pronounced.
That is correct. You're on it.
Okay. I'll mispronounce it just for the heck of it. He's at WBND in South Bend, Indiana, which is the ABC affiliate.
That's correct.
And he's been there, well, for like, what, 2 years less?
We started up, I was here the first day that this station launched, which I believe we're on our 4th anniversary.
Okay.
I was in 2011. So
Yeah.
I've been here since day one.
Yeah, but he is a native. You are a native Michigander. Is that how
I don't know if we even go back. I'm from Michiana. I grew up in the South Bend area. I went to Purdue. I did 4 years in Western Colorado where I started my weather career, and then I got to move back home, and it's been a great experience. I moved here because it is, just like Iowa, one of the active weather markets where I have 4 seasons of active weather. It's not just, we wait till monsoon season or something like that. It is all 4 seasons. You got to be on your toes for some sort of setup.
So when you've done some severe weather coverage in the past, and
Absolutely,
and I've seen it, but before we get into the 65 outbreak, we'll do comparisons to like 65, and if something like that were to happen today, but in your time, if you look at 65 and you've done a lot of work on that and studied it, has there even been anything close to that in your time on television, which I doubt, or any time in maybe like the last 20 years in that area, or since you've been around while you were growing up?
I could say absolutely not. Even since I've been around, the fact that we had 5 major tornadoes, 3 of them were F4 and 2 of them were F3 tornadoes, and since 1950, in my research doing this, there have only been a total of 12. So, that's the big story there. There's only been a total of 12 of these tornadoes since 1950. And in my childhood and then being on air here, the only one that comes to memory in my lifetime is going back to, it would have been 2001. And I remember this because I was out on the football field. We had football practice, and we all got evacuated in, and it was an F3 tornado that started on the west side of South Bend and went through neighborhoods where some of my friends lived, a lot of people that I went to high school with, they all lived. And that was an F3 tornado that went through the Crumstown tornado back in 2001, and then I was out west when the Napanee tornado moved through as an F3. But to have 5 on the same day, large tornadoes, that it just doesn't happen here, and that's what's so incredible about 1965.
Now, the area, when we talk about the area, pretty much what would be considered the South Bend TV market is pretty much what we're describing, and you can describe it, and I'll kind of describe it. It's fairly tiny. It's not like a state, or it's like these big, huge markets that are hundreds of thousands of square miles. It's pretty tiny.
Yeah, we are actually we share a weather office with Fort Wayne. It's like the South Bend Fort Wayne area, and depending on kind of how you count it, there's only about 12 counties. Chicago edges in on us, and so we're only talking about 12 counties of northern Indiana that we really serve. It's still a pretty good population. But yeah, and to have that, it just doesn't typically happen here.
Now, before we go into 65, the event, we'll compare to if this was 50 years ago and you compare it to today, it's more developed. There's more housing, more stuff. And when we did our test with the infamous twin tornado, that we'll talk about that in other tornadoes, the area that was in then was pretty much rural. There was very little housing there, a few houses and whatnot, and of course the trailer park that got hit. And today it's a shopping area. So if a tornado like that was to happen now, and in some of these places, it could be much worse.
It absolutely could. The only other pushback is that, hopefully with our warning systems, is that they are much better. I know we'll talk about that as well, as that, that's what came from 1965, but yeah, that's the other part of this is typically, even nationally, you can have big tornadoes a lot, or not typically a lot, but when you do have them, are there actually buildings and places in that path? And if these tornadoes were today, there would be a much higher population in the path. And, we saw 65 local deaths back in 1965 just here locally within the South Bend area, mostly towards Elkhart County. You do that today, and again, that it could be much higher even with the warning that we have now.
Okay, so we're going to go back to 1965. I'm going to play a video. It's probably not one of my best videos, so if anybody wants to go crazy about my video, so I am going to screen share it first so it can play. Okay, so this is the beginning, because this goes back to the beginning of the outbreak. So now I got to play it. There's no audio, so don't. I'm hoping it's in it. It may not be. Is it? Did it? Maybe it doesn't want to. Boo. Okay, well there was there was wasted time for me to do it because I don't think it did it. Never mind. We're not going to do that now. Okay. Anyway, that's what that video was going to be, was to describe the first tornado in that event, which occurred at just before 1 o'clock in the afternoon. It touched down, and I did this video on Wednesday, okay? And I found out a lot more stuff since Wednesday. It's surprising how much stuff I was able to find out about the first tornado on Wednesday, in between doing all the severe weather stuff that was going on Thursday. The tornado touched down, the first one of the day, touched down 3 miles east of Tipton in Iowa. It was actually seen on, oh my, it was actually seen on radar from the radio station in Cedar Rapids. And they told people in the area about where the tornado was. That's going to be interesting, whatever that. We're getting alerts already. I'm sure Tom is wondering why it's doing that. But anyway, so the tornado moved. It doesn't.
I'm not sure. I have my. I was plugging my phone in, so I'm getting a little pushback. So now I think we're good.
Anyway, if it does it again.
Yes, I trust this computer. I'm here. I swear I'm here.
It's going to do it again, I swear. It touched down 3 miles east of...
All right. I'm going to go tell it don't trust this computer. I'm fine. Good. All right. All right. I think I'm here.
Anyway. It's going to... some more. 3 miles east of Tipton. We make it through this today. 3 miles east of Tipton. It went to the northeast. The first person, it hit several farms. One person south of Clarence, between Clarence and Loudon, Richard Dirks, was fatally injured. His wife and son were at home. They were minor. They were injured a little bit. He was sent to University Hospitals in Iowa City. He died a couple of weeks later. But technically, he was the first victim to die. Or he was fatally injured, but he didn't die. He was probably the last person to die from the outbreak. So that was at 1 o'clock. And then there were several other tornadoes in Iowa, into Wisconsin, and into Illinois. In fact, it's interesting. I just went back and looked at it again. There were several tornadoes from that outbreak that were very close to where this Rochelle tornado was yesterday. One hit Crystal Lake. One went north of Rockford. There were several along the Wisconsin-Illinois border.
And we talked about that on our test on Tuesday. You're saying, well, this setup when we were preparing for Thursday is that, it wasn't exactly like the Palm Sunday setup, but
yeah.
It was kind of, it was at least similar, and you saw what the result was.
Yeah, and when I went back and looked at it again, the Palm Sunday 65, you have a low pressure center moving through Iowa, which is interesting because yesterday the low pressure moved through Iowa. There was the warm front lifting up, and most of the tornadoes were forming along the warm front, the ones in Illinois.
Yep.
And the same thing happened again. If anybody goes back and looks at some of the radar loops from yesterday, April 9th, and you see kind of like this boundary stretching across northern Illinois, it looks similar to what happened similar, not exact, but similar to Palm Sunday 65, where you have all these tornadoes seemingly forming in an arc pattern. And it even went into Indiana as well, and we'll get to that, where it formed on an arc. But unlike yesterday, it only was in a concentrated area, whereas in Palm Sunday, it stretched all the way into Indiana, Michigan, and into Ohio well late at night.
Yeah, we got very lucky yesterday in the fact that we rained out our instability early in the day, and that can happen. And and that's the thing with a lot of severe outbreaks. It's the small details early in the day that can really impact the storm setup later in the day. If you get clouds and rain, you're going to rain out your instability. But back into portions of Illinois and Iowa, where the real severe happened yesterday, just like on Palm Sunday, it's because it was just bright, sunny, and clear almost most of the day, and they had enough time to really get that instability going.
And the weird thing about it is back on Palm Sunday 65, the setup was the same. It was sunny, it was warm, it was like the first real warm day of spring, and a lot of people, being it a Sunday, they would go to church, and then they would go driving around. A lot of people did that back then. Not many people do that now as much. But people on a nice warm day on a Sunday, they would go out, they would like make a picnic and go out and have that and drive around. From what when I look back on the tornadoes in Indiana, the first tornadoes moved in before 5 o'clock in northwest Indiana.
Yes.
And there were several storms producing tornadoes. So you can go into the first one and whatnot, and I can get the stuff prepared because I have the stuff ready.
And the biggest thing is that they were long track tornadoes too that formed, which is also not typical for here to have. And in some of the write-ups that I've read, is that the supercells that form, which in itself we rarely get supercells, let alone tornadic supercells here in northern Indiana, and these were long-lasting, and their lifespan was long-lasting even for supercell standards. All 5 of these tornadoes on Palm Sunday that hit the South Bend Elkhart area were over 20 miles. Most of them were in that, at least I've read some that they say the 25-mile range is what we make the threshold for the long track tornado, but 20 is pretty close. All of them were above 20 miles. The longest was over 40 miles, or at least close to it. 37 miles was the one that went across the northern half of Elkhart County. The one with the famous tornado, with the twin tornadoes that went through the trailer park in Dunlap, was 21 miles. So again, just long track tornadoes, which don't happen on the whole of all tornadoes that much, but to have 5 of them in one day in pretty much the same hour or 1 to 2 hour time span, I can't imagine covering that. And, we saw the Moore tornado outbreak, and we saw all the tornado outbreaks in Oklahoma.
Yeah.
Maybe 1 to 2, and these were all very serious. But to have 5 tornadoes almost simultaneously on the ground, and to cover that on air through your populated area, I almost can't imagine that nowadays. It'd be a lot of work, but a lot of the time when you have the dangerous tornado, and you see this anywhere in any major TV market, or even on the Weather Channel, they're going to pick the one that's going to have the highest impact to the highest population. They're going to focus on that one. In this case, you don't really have that choice. I can imagine myself being on air. I would need to hop around and be like, hey, you've got this one. Wyatt, you're in the path. and then Dunlap, you're in the path of this one, and then we go on to Wakarusa towards the Bristol area, and trying to tell all these locations, hey, now you're in the path of this storm, to keep that straight. I can only imagine that situation. And then how they actually covered it was there was a radar site in Chicago, and someone was on the phone in Chicago talking to the Weather Bureau at that time in South Bend, and they were trying to issue these tornado alerts. So I can't even imagine trying to get this straight, playing a game of telephone for someone else watching the radar site. It's amazing to me, and it's unfortunate that 65 people died, but most of those were the fact that tornado hit right on a densely populated trailer park with little to no warning.
Now, I have the tracks of the tornadoes that were south and southwest of South Bend, and I mean, you look at the times, because this was back when now back then, for those that may not know, the South Bend area used to be in the central time zone back then, which was true. A lot of Indiana was in the central time zone back then.
Correct. During that time, we just didn't have a time zone. We didn't observe daylight savings time. So that time of the year, we were Central Time.
Yeah. So, and I think there was daylight time in the 60s, but I'm not sure it existed. But anyway, that's why it's in Central Time. So don't anybody start going crazy, because I think the time was true. But anyway, and you can see there was this storm here, this long one, then this one, and then this one. Now they're lettered for a reason, because they're different thunderstorms. For example, this K1 storm that went through South Center, which was near Wanata, there, and then it comes out this way because this part goes off screen. And then that storm cycled, and then it produced this one down here, and then kept going. And while another storm was producing this long one that we're north of La Paz, and then it went through Wyatt, and then it went north, and then it produced the one near Wakarusa. So at one point, this thunderstorm, this one we'll letter J, and this was done by Ted Fujita. This is in Monthly Weather Review. This J thunderstorm at one point was producing 2 tornadoes at the same time, while, now if you notice, this K storm, the storm was an hour later. So here's a case where you're, let's say, down in this area, one is going through, and here comes another storm that could be producing another one. And this is, nowadays, people would be like, there's video, there's storm chasers, this and this and this. But this is 1965. Black and white, you're getting radar from somebody on a phone, and it ain't no cell phone. It's a corded phone, and it's probably bad reception. You'd probably have better way of getting it through a telegraph machine than anything else. But so when you have this many tornadoes, it's almost maddening, like you want to pull your hair out.
Again, that's where I just can't even imagine. Even nowadays, it's stressful to be on air for hours at a time, than to go through this and have all this happening simultaneously. Also, with the fact that when you're on air in a case where you have the tornado, which I talked about, that main cell is to Wyatt, then started cutting into Elkhart County after it cycled, and then you get another one an hour later cycling towards the north, is you're focused on one area, and then you got to kind of have the person off screen, everyone keeping track of that second cell that's going on. And, it's just it's an incredible outbreak that they were able to do what they did, and we're lucky that towards the end of these tracks of these storms, that they got into what then and still is now a unpopulated area for the most part.
Now I have the famous twin tornado right here. It's on my screen. That is, this storm right here is known as the J2 tornado, which is right here. That was the second one of the letter J. And there it was right here. And as you can see, it started, now if I have to go back to the other map, it started right here, and it hit this trailer park, which is when it was in this position right here. And that was at about 5:30. 45 minutes later, another tornado hits just north of there in Dunlap. So they're still trying to clean up, and I would assume back then there was people coming down from Elkhart, and if they were trying to come down, here comes another tornado and it sweeps them away.
Yeah, on the same path. The interesting story, and the other thing that's amazing about this is that Paul Huffman was not a tornado chaser.
No.
He was a day-beat photographer, and they were starting to get things over the wire, over the telegraph wire about these tornado outbreaks and saying, hey, there's stuff approaching the Elkhart area. And they just said, hey, why don't you go down and take some pictures? And not only did he get on the, what would be, if you're a chaser, the proper side of a tornadic storm, which would be he was to the south and west of it, so it was always going to continue to move away from him. That's probably luck, but hey, thank goodness, and still to his credit, he was not a tornado chaser. He was just a day-beat reporter. He didn't have all the gadgets of the day with cell phones and radar scope and everything like that, and knowing the network of roads and everything like that. He just knew how to get there. He managed to get what I still think to be the most famous tornado photo of all time, and he did it in 1965. There are chasers now that wish they could get that photo, and he did it. I mean, he got it at the best visual point of the storm. It wasn't rained out or anything, and he got that photo. Actually, there's 6, but he got that photo too.
Yeah, there are 6. This was the 4th in the series.
Yes.
I think 3rd in the series, 3rd or 4th. But and it proves, even though you look at it and you're thinking, oh my gosh, it's 2 tornadoes. It's what you would probably consider this the thing on the right. It's more than likely it's pretty much 2 vortices going around each other, because it was actually the same tornado. And we'll look at it a little later when I'll drop down. I feel like I'm doing the whole monthly weather review on here. But when you look at the 6 pictures that Paul Huffman, God bless him, he recently passed away this past fall, but for those that may not know, that you see the tornado coming in as one funnel. It then splits into 2 right when it crosses this road, which is Highway 33, hits the trailer park, but what may have not been known is only one of these funnels, one of these tornadoes that you see on this picture, only one of them actually hit the trailer park. The other one did not.
Yeah, we always see it, of course, with still photography, that short period of time, but with the 6 photos, which have been taken in relatively short sequence.
Yeah.
This is more likely, and that's why it's even labeled, when you look back at everything, it's not like they labeled 2 tornadoes. This is likely just a moment when it was a double vortice tornado, and then merged kind of back into a single vortex.
Now, when you look at these times that they're showing here, these tornadoes, they're moving very fast. They're not going like the 20 or 25. If you have a storm that's down here at 6:15 and it's over here at 6:30, that's not slow. That's pretty quick for a storm to move from south of Elkhart all the way to near Scott, northwest of LaGrange. That's about what, maybe 40?
Yeah, you get there. You get to that 20 to 40 mile range, and you bring up another good point. Again, trying to think about it, what it would be like today. Is even with the best technology that we have, even with the fast looping radar, these storms would still be outrunning the radar scans by a couple of minutes. And yeah, we can estimate that it's moving this far, you need to take shelter now, but to kind of have that feedback, just add that to the next variable. You have multiple severe thunderstorms happening at one time in a very short period of time in an area where you get over some densely populated area, especially now for right now, and now you have it kind of outrunning that radar scan where it's going to make some big jumps, and you're telling people, well out in front of this storm to get in their shelter now.
Yeah, and I have it off because I'm going through because several of the other tornadoes that were in Indiana were further south and whatnot, but I'm going to go down to, okay, here we go. Now I gotta share this back. Now here is, and we're gonna go back to this. Okay, this is the twin tornado again. This is the fourth in the series. This is what it looked like not long before that. Paul Huffman took all 6 of these pictures. You see, there's the twin tornadoes, looking northwest or northwest down Highway 33, toward the direction of Dunlap and Midway Trailer Park. This is looking due west. It's not a twin tornado, and it immediately went from this. This is labeled A. So you're going to see A, then B, then C, and then D, E, F is on the other side. You go from A, whoopsie, went too fast. Me going too fast on this. We go down here. You see, it looks like it's lifting here, but that doesn't mean anything.
Yeah.
But if you've noticed over here, remember the twin tornadoes that you saw in D? Well, now it's kind of hard to tell. You can still see one here and one here.
And that may be getting into debris as well there.
And then here's the C. This is when it was before it crossed the road. You can kind of see there's one, but the other one by that point is on the ground. There's actually 2, but this one right here is hiding the other one. So at that point, and then by the time you get to F, when it's looking almost east-northeasterly, or almost, in fact, it's actually looking north, almost north, slightly north, or almost north. It just looks like a big ball of nothing. It's hard to see at that point. And I could go back, and I'd have to go back because it would be up here, the damage to the trailer park. And there's so many images here. There's tornadoes here. There's that. Okay, here, right here. There is the mobile home park. You can see there's the damage. A lot of these trailers, nothing happened. That's typical of tornadoes. You could have these mobile homes completely just demolished and destroyed, and some of these are still standing. Maybe flipped, but they're still standing.
Yeah, it was like a legit day, like the plains, like one of the worst twister days you would see typically of Oklahoma or the Texas Panhandle, but it was here in northern Indiana, and typically we see squall lines, we see bow echoing lines of storms where when it rolls through, everyone gets roughly the same amount of damage, unless you get one part that's bowing a little wider, or you get some small tornadic spin-ups. This, I mean, it really was hit or miss. For the most part, when you look at the cells that popped up, there are about 5 cells or so. There are some people on that day that, were probably saying, wait, what happened? What tornado? And literally just, 15, 20 miles away, you had damage like this.
Because the areas that were hit, Elkhart was not hit. South Bend was not hit. It was everywhere south of there. And a lot of people, because the TV stations at the time are in South Bend, or South Bend, Elkhart, in that area. They're more or less, and it might still be the case, I don't think it is, but it could have been then, that they care more about the people in the big cities. South Bend, Elkhart, all the big cities. It goes through, like, middle of nowhere. It's going to be a lot harder, and it's even the case today. If you go, like Fairdale in the tornado yesterday, a town's about 150 people.
Yeah.
Now, there's a lot of chasers that were around it. They saw the tornado. The damage, everybody saw it. But if this was a tornado 50 years ago and it went through that same town, you may not hear reports about it for hours. And that was probably the case in some areas. Not especially this. This was fairly close, and this was seen. In some areas, you may have not heard about the damage for hours.
Yeah, which again, to his credit, those Paul Huffman pictures makes it that much more amazing. He wasn't a chaser, and they were hearing rough reports of tornadoes in the area, and they kind of got a heading, and they got the details off the legit weather wire, off of the ticker tape, and he was able to capture those photos and document that day and that moment in a way that has almost never been seen before. Maybe Joplin, where you had a lot of the chasers, they were chasing the storms, and then they came upon the damage and the injured almost instantaneously. And of course, a lot of them did help out, thank goodness. But to do that, again, in 1965 with as little information. I can imagine. I think of reporters I work with here who, they understand what a tornado is, but they don't have the training. And then to not have any of that, again, radar scope or anything in your vehicle, and you did it, and you got the shot. I mean, amazing. I tip my hat to him, and God rest his soul.
Now, here's the tornado, the twin tornado. We're spending all our time on that, but there's a reason for it, because it's the famous tornado picture of the event. And as you can see, this was where Paul Huffman was. This is where the camera shots were taken. Where 1, 2, 3, 4. Number 4 was when it was the twin tornadoes. Okay? So as you see, when it was one tornado. Then it was a big tornado. Then it split into 2 tornadoes. Then you had, this is when it was the 2 twins. This was the right one, and then the left one. And then the left one, right one, and by the time you saw that northern one, the last frame, all you saw was this one. This one was now shrinking and dissipating. So what more or less you could easily say is that this tornado, the black circle, we'll call it the black circle, that this could be a case where you have one tornado, another tornado forms and replaces the original one. So in turn, the white one is not the original tornado. It's actually a new one that formed off of the first one. And it has been shown that this happens quite often. It's considered to be one continuous tornado, but it wasn't the same tornado that did it. Where you have a black circle and then the white one coming in behind it, and that ends up continuing it. One example is Heston, Kansas in 1990. You had that big F5 tornado that hit Heston, Kansas. A new tornado formed, then that tornado widened, and the Heston tornado shrank, and then they merged, and then the second tornado continued. And the first tornado had died, but it was considered to be one long tornado track with 2 tornadoes. And you could easily say this was probably the same thing.
Yeah, and and that's things that especially when you're watching a lot of tornadic storms just on radar, sometimes you don't always see that. You see maybe the upper level rotation, but of course, depending on where it's at, it's hard to tell because you don't have that low level scan depending on where the radar site is. And to have this, eyewitness view, we can really kind of dissect this. In a lot of storms, you can't really see, well, is it one vortex, and then it kind of spins up another one along with it all the time.
So when you look at it, and you see that here, you see that the tornado track did kind of deviate a little bit. You see it deviate, and then it went back in the same direction. Now, when we look at it, now here's the entire outbreak. Now it looks a little odd because it's a bit weird, but you can see, you look at this, it shows the wind kind of blowing, because this is pretty much the radar echoes. They got radar data back then. You see the tornadoes at the beginning, when they were in Iowa and into Illinois, they were moving northeasterly. But when they got into Indiana, they started turning more east-northeasterly, which is interesting. And then they all were pretty much going in that same direction, east-northeast at the end. So that was kind of interesting at that point, that they started in one direction and then they kind of went into a different direction.
I think that's just a sign, kind of the whole system, the way it moved through, and we even kind of saw that yesterday with Thursday's system as well. Is you had a predominantly southwest to kind of northeast direction, but then as that low kind of progressed across the Great Lakes, it kind of changed up a little bit. We had some stalling, and the way it kind of occludes or kind of closes up, you're going to kind of see that change in wind direction. And once you see the rest of the outbreak map, there really isn't a lot more past there. There's one more that kind of goes up into central Michigan, or the center part of Michigan, but then this is kind of towards the end of the event.
Yeah, and that's what was, because I did this because because there were several. Because this was interesting. Because Ted Fujita went nuts about this. Because you have a lot of this type stuff. You have modes of what the tornadoes do.
Mm-hmm.
For example, when you have parallel modes that are pretty much the storm is moving in this direction along this line, and the tornadoes move and occlude, and a new one forms and occludes, and it does it and it keeps doing it. Then you have ones that, like the combined ones, where they go and then they kind of just continue along the same path as with the storm kind of in that same direction, and then you just have ones that are series ones where they just go along the same path. And from what I know, the ones in Indiana were pretty much, in Michiana, were pretty much these. They just stayed pretty much moving in about the same direction.
What I've read is really the factor of that is that it was the supercells themselves that were mostly the cause of it. Of course, that's with most long track tornadoes, but they were able to sustain themselves and not occlude. It was just the right setup that these were able to last. The real interesting thing is how long did these supercells actually last? Because we know that the tornadoes were on the ground for an excess of 20 miles for most of these. These supercells, their lifespan was even longer than that, which is without kind of faltering or kind of blowing up and then kind of blowing themselves out, they sustained themselves for that long.
Now, this is radar data. This is what back in 50 years ago. This is how they were able to determine tornadoes. This is really hard. Try. Nowadays, it's so simple. You could see debris balls and hook geckos and all this stuff. But look at this today. Now, most TV stations, only a couple, had their own radar, and it looked just like this. Would you be able to find the tornadoes? I mean, some of these, it's fairly obvious. This is hooking, and it continues and whatnot. And some of these you can easily see, but it's hard. It's difficult back then.
Yeah, I mean, that's the one case that we're lucky with these to have the radar data in this form is that these were supercells and these were slam dunk. I can only imagine what they would look like on today's radar. I mean, they would be more I remember the Moore vortex when you would just see that in the velocity data, and it was the sharpest couplet you would ever see of just blazing red and blazing green on there. These were, luckily with the radar that you had back then, still very visible. If this was mixed up with another line of storms or maybe had some high rainfall, you may not even be able to notice it like this.
Yeah, I mean, I'm trying to deviate which ones are which. I believe, and I'd have to look at this more clearly, one of these is the one, I think it's this northern one right here, that were the ones in Indiana, I think. It's very difficult because they're so hard. Mm-hmm. But I think because you can see this one looks linear with little hook shapes, and then you have this one that looks like has a hook here, and it kind of disappears. But you're getting further and further away from the radar, so it's getting a lot harder to see it. So
yeah, this is radar data. So this is a radar site out of Chicago. So where this is at, this is already pushing 90 to 100 miles away.
Yeah. I believe this family K, is one of them that produced tornadoes, and you can easily, I mean, this one here and this one down here, you can see, it looks like you have a storm blowing up behind this one. It merges, and it probably was producing a tornado at that point, and then it moves on. And I mean, people today don't realize how well they have it when you can see the nice pretty colors and the reds and the purples and the debris balls, and back then it was just a big black mass.
Yeah, I think a lot of it was they could tell that this was, I mean, especially from that far away, again, 90 miles away from the closest scan, maybe when the storms were the closest, but as they start pushing through Elkhart County, they're already over 100 miles away from that radar site. and it was probably from between ground reports that said, hey, there's big tornadoes, and we know they're kind of with this cell, and they just, that was a time when you had a radar op, someone who's kind of looking through binoculars at the, or I would say binoculars, but you looked at the scope, and then they relayed their information to somebody who's on that phone, and they relayed that to somebody on the other end of the phone in the South Bend weather office, who then was probably on the phone with other people trying to get this message out. I mean, the game of telephone, I can only imagine, the intensity when I'm just on the air myself. Imagine playing a game of telephone trying to get that information out.
Now, this is it's considered a NEF analysis, which nowadays would be considered a satellite image, because you get satellite images like this. Back then, you didn't. You maybe got one every 5 minutes, and this was from Tyros 9. And it's not geostationary. It wasn't. It would just go around the Earth. And it just so happened that it was in the area, close to the area, when this outbreak started. This is pointing at the first thunderstorm that was forming, the one in Tipton that I mentioned in Iowa. And you could kind of easily see the front hanging down like this, the low pressure right here, and kind of an arc type thing forming here or here. And isn't it interesting that this area right here, which is near Tipton, yesterday the tornadoes were in from here up to about here. And where were the tornadoes in Palm Sundays 50 years ago? There was couple up here, the ones here, and then they went all along through Michigan and down into Ohio and central Indiana. There was hardly any down here in central Illinois. They were all here, 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 and all along this. It seems very interesting that there are some similarities given the fact that you look at the low pressure here. The storms formed in eastern Iowa. The first storms formed in eastern Iowa, which was interesting. The first storms from yesterday formed in Iowa and Missouri.
Yeah, and what you also see that's typical here, and even there, we see in this part of the country are bigger tornadoes, the F3, 4s, and 5s, are along a buckling warm front. Not just the classical Norwegian model where you have a kind of a nice arcing warm front, but even yesterday when you looked at it, it was a messy kind of front. There were ups and downs and buckles in it, and what you get with that is you get a lot of vorticity and a lot of rotation along that, wind going a lot of different directions, and that's how we get our spin-ups into our supercells. The cold fronts, typically, once you get along and crossing the Mississippi, they start to fire some stuff, and we saw tornado warnings with cells, and it never really came together, but it wanted to was form a squall line. And so what typically happens is we get that squall line, so we get tornadoes, but the bigger event is usually the cold front sweeping through, where we see the number of most of the reports are actually from the straight line wind, and you have all the people that say, well, I swear it was a tornado. And you're like, no, it was just an 80-mile-an-hour wind gust, but it's still just as deadly. And to put another thing in perspective is that, yes, 1965 was, at least as far as we know around here, the most deadly day for severe weather, 65 local deaths. But since then, and the latest climatology from our local weather office from 1980 to 2010, doing the number of deaths from severe weather, we've had 7 deaths from tornadoes, and we've had 7 from straight line wind. And then just last year, we had 2 more on July the 1st, and with the most recent data now from 1980 till now, there are more deaths from straight line wind than there are from tornadoes.
And that might be because people aren't, they're thinking, well, for example, people aren't paying attention to severe thunderstorm warnings as much as they probably should. And we've discussed that on this show numerous times.
Yeah, and that's my biggest thing working here, and with all our outreach in what we talk about, it's my mission here is to is when we break on, is like, I get what a severe thunderstorm warning is, and we tell people, yeah, you need to get away from windows. But as soon as I see the velocity data starts pinging 70 miles per hour or more, I'm on air, and we're on air the whole time. We treat it just like a tornado warning, and I try and stress that so much. Take shelter now. And what these deaths are, especially in this part of the country, is it's large trees falling onto houses. And sometimes it's when people are asleep, or sometimes it's you just don't know what's above your head. And it's very typical for around here. And, the tornadoes get the press for good reason. But, again, when we have severe thunderstorms, I treat them just like tornado warnings when we break that 70-mile-an-hour threshold.
Now, I have the setup from Palm Sunday, and you can see there's the cold front, there's the warm front, then there's this thing, which looks weird, and it's interesting, to say the least. But it seems really interesting. You have this moist air that pulls up in kind of a narrow area, which is similar to yesterday, because in here in Iowa, where I'm at, in eastern Iowa, the last couple of days we'd had temperatures in the 40s and 50s. It was kind of miserable. We were getting showers, but they were kind of dissipating because it's been pretty dry here. So any rain that seemingly comes is dissipating because the ground has been so dry. But this was the first day yesterday where the dew points came into the 60s. It got really humid, and I had multiple thunderstorms, not non-severe, at least where I'm at. But it was interesting to see this front in this pattern, the arcing warm front, but no storms to form down here, at least non-tornadic, but they seemingly formed on this warm front. Of course, this was at noon. This was well before the tornado started. But it's almost as if you knew that something was coming. If you have something where you have dry air pushing in like this, the warm air coming up, something's going to happen. But from what I gather, most of it came along this warm front. And a lot of people, and I think that's the case today, they look at this and they think this will be where the tornadoes will be.
Yeah.
Along the cold front. And it should be noted that with the Rochelle Fairdale tornado yesterday, that was not on the cold front. That was on a boundary. It wasn't the warm front, but it was a boundary that had been set up where there had been a wind shift line.
Yep.
And the same thing, that same wind shift line came through where I'm at midday. We'd had southerly winds and temperatures were in the low 60s. The minute that boundary settled south, it was moving very slowly. The minute that boundary went south, the wind shifted to the north, then northeast. The temperature went from 60 to 50 in about an hour. And then it was miserable the rest of the day here until I got a thunderstorm. This was after the tornadoes had crossed the Mississippi. I got a thunderstorm, and I thought that was the cold front. No, it wasn't. That storms moved through, and I went outside, and the temperature was even warmer, and it was more humid again. And I was like, I don't know what the heck was going on because I was totally confused at that point.
Yeah, there was a lot of overrunning yesterday, and even the night before, we had temperatures in the 40s and 50s, and Wednesday night into Thursday morning, we had incredibly loud thunderstorms. It had nothing to do with what was the typical setup when you're like, oh, it's a hot, muggy night. No, it was a cold, relatively cold night in the 50s, and we actually dropped off into the 40s, but we had some very loud thunderstorms because we had a lot of overrunning, and that's what this system is. It kind of stalled or took its time, and then this front kept buckling for days. The warm front would buckle kind of up and down. There's a lot of overrunning, and so you had not just the warm air aloft and the overrunning with those thunderstorms, but it's just typical, even going back to Palm Sunday, that buckling line along that warm front for the Midwest, there's just so much helicity, there's so much spin, and the way you describe it, it's very indicative of what may have been the setup or what it may have felt like in some areas on Palm Sunday 1965 is the twisting winds at each different level made that setup, and that may be what caused those supercells to be so long-lived as well when they went through is that you had just that right amount of wind shear that just kept them perfect and kept them focused and not occluding themselves for such a long distance.
Yeah, I have the 850 millibar chart from 6 o'clock. Now, the cold front was in the area, but it looks like, I'm assuming these black dots means that's where tornadoes were occurring. And some of them were close to the front, but maybe right along it, but not many. So there had to have been, more than likely, boundaries, outflow boundaries set up. For example, if you had that one tornado that was an hour or 45 minutes before the other one could have been enhanced by a boundary left behind by the other tornado.
Yeah.
So and that might have been the case with a lot of the tornadoes in Indiana, in northern Indiana, and maybe in other places, where you have one tornado and then it leaves a boundary for another storm to go through and produce another one. Mm-hmm. And that might have been the case with almost all of them. It wasn't the cold front, it was one storm went, and then it just left boundaries for other storms to start rotating.
Yep.
So, but you could see it's pretty much, the low was occluding, so, and there was the warm front, so the storms were forming, but toward the end it was likely linear with little spin-up tornadoes, because a lot of the strong tornadoes were occurring late afternoon into the very early evening, and then after that the tornadoes, if they were still strong, were likely in what would be considered linear storms to a certain extent.
Yeah.
So I'm going to unshare that and drop down, because what we'll have to talk about is later, in fact we'll probably talk about it now, the watches and warnings back then. And we discussed this in our test, and this is something that we'll have to really go forward. Back then, there were no watches and warnings. They weren't called that. They were called tornado forecasts and tornado alerts. And we could go into that because the public didn't really understand what that meant back then.
Yeah. And even now, and the biggest thing is just going to conferences, and it's amazing just how we've developed since then, even through now, and we're still working at it with the latest SPC outlooks, which I don't know if the slight, moderate, enhanced, I think there's still some work to do on that. I see what they're going with. I think people do understand the stoplight scale, but I'm getting off topic here. There are social scientists with NOAA. And I found that very interesting, and I actually, being a broadcast meteorologist, I have to know the weather. But I really also have to understand social sciences as well, especially with the way we use social media nowadays is, a lot of people, they just post to put whatever out there. And you really start to have to look for messages that work and get their way across. And before the watch and warning setup, it's clean, it's simple, and we drilled home a watch. Conditions are right for possible development of a thunderstorm or tornadoes. A warning, it is very likely one is happening, or it's imminent that it will happen very soon. Take shelter now. And it's probably one of the greatest things that we had, and it's been copied. If you look at weather services worldwide now, they have some sort of watch and at least warning type setup in most cases.
And it's interesting because it more or less came because of this event, because nobody understood, and this is probably the first time there was maybe what I would consider social science at work, because back then there was no watches and warnings. They were forecasts and alerts. Nobody knew what that meant. So they went to something more simplified. They know what a watch and a warning means. You'd hope they'd know by now.
Yeah.
So back then, there was the problem with where are these alerts and forecasts going? Because back in those days, there was no weather radio, there's no cell phones, there's no crap apps or weather apps or anything else going to tell you what's happening. You were pretty much at the mercy of either radio stations or the TV stations telling you about them, and in some cases, I think it may have been back in that time, they didn't want to probably broadcast at least the tornado forecast, known as watches now, because that would incite panic.
Yeah. Yeah, I can. Yeah, only imagine. And then even if you're, on the warning, there's almost so much. I can't imagine even doing wall-to-wall coverage. Just even getting enough information to really break into program and tell people. I mean, just saying, hey, tornadoes are hitting in this area, and to relay that, 2 or 3 times via telephone. How we've come so far today. We're not just issuing watches and warnings. When you see the latest social media alerts on that, we have the Polygon, which was a further development of that, to really focus in on this is the area in the path, and now we're getting information on the population centers that are and how many people are populated in that area in the path of this storm, and we've really kind of focused in on where the danger is and letting people know within a pretty good range of miles, if you're in this path, you need to be taking shelter.
And another thing that came off of Palm Sunday, 1965, was that they needed more radars, because having a radar in Chicago for tornadoes in north central Indiana is if we had the radars like that now, people would probably start yelling at Congress people to say we need more radars because this is a safety hazard.
Well, I mean, the interesting thing about that is we didn't get a Weather Service office with a radar. That wasn't built until the late 90s here. We actually were kind of in this, and now it works really well because of how we're spread if the site were to go down. We have Chicago, Grand Rapids, and Indianapolis that can pretty much cover our area. But it was pretty obvious that we needed one here, and thank goodness they built one in our IWX in North Webster. It's a great office and a great site, but we were still kind of always in this kind of radar dead zone. But now we have that coverage here as well.
And back then they had WSR 57s, and then after 65 they started putting in more 57s, and then the 74s. And then most of the 74s, and I think back later on in the 80s, those were colorized. So you actually could see some colorization. You still, in some cases, still had the black mass, but it was colorized now. It was I think all the 57s and 74s were colorized in the 80s. So at least it wasn't, you saw a big black mass and you didn't know what you were looking at, like what I showed earlier. You at least could tell something.
Right.
But today, it's with dual pole, and there's radars all over the place. There's still some dead zones in tornado areas, I might add. We've talked about this before.
Yeah, one actually close to here. Once you get out of South Bend and you move into, there's kind of a dead zone across the southern half of Michigan, between South Bend and Toledo. In some parts of Michigan, it's kind of a dead zone. In fact, there was a tornado there was a tornado warning issued for the far outreach of my DMA yesterday in St. Joseph County, Michigan. And we got a report of a funnel-looking cloud, and they issued the tornado because it was at the edge of our radar scan, and that's about as close as you're going to get, and you're kind of overrunning the top of, well, I guess there's a couplet, and a warning was issued. How much it's verified that has yet to come back. But the closing these dead zones, and they've done a very good, of course, with populated areas as well.
So, and we kind of went along with this. Where we were 50 years ago to where we are today, things are much better.
Absolutely.
They're still, even back 50 years ago, you were still getting pictures. It's surprising there's so many pictures of tornadoes from 50 years ago compared to today. You'll get pictures, videos, you'll get people calling in live now. I don't know, back then you could have probably done it, but it would have been odd. And everything today, it's like now. Back then, it was you would get a tornado report that hit X, let's say Midway Trailer Park, and at that time, if you're getting an hour later, there was a tornado in the same area just north of there, and some people would think, maybe back then, that it was the same tornado, and they had just gotten that report, but it was a different tornado. Whereas nowadays, you would be able to tell that it's a different tornado from the one you're getting a report on.
Yeah, I mean, the communication we have now is amazing, and the radars to kind of separate that to easily say, that's not the same one now, in almost moments notice compared to hours of notice, um, is a great accomplishment, and I think to an extent, the public is more knowledgeable of weather compared to what it was then. You still have people that still don't understand. Maybe they kind of understand a watch warning, but most people have a pretty good idea. And there's a lot of people that understand radar enough that, yeah, they didn't go to school for it, but the displays are so good now. Again, if you download Radar Scope, you may not see everything. You may not see the dry line on the radar and everything like that, but when there is a sharp couplet, that means a tornado. You may not know exactly what the red and the green means, but you know that there's a tornado there, and you know what that means.
So I'm going to, wait a minute, I'm going to bring up something. Just a minute. I am going to, okay. Now we showed earlier the radar images, the big black yucky masses of tornadoes. Now this is something that I had to send to my sister yesterday, which and she was in Clinton, so, and I'll point this out. I think it's pretty obvious now. We can easily see tornadoes a lot easier now.
Yes. Absolutely.
I mean, this was, and you didn't have this back then because there was no Doppler. It was just all you saw was the rain. And today, you can easily see a rotation clear as day. And that is a lot better than it was 50 years ago. So,
not to mention we have the access of just looping and going back and forth and the rock, and a lot of times it's just literally the latest scan of the radar, and they're going by, is there a hook there? And there are some tornadoes, Palm Sunday I think was a little different. You could kind of see a little bit more because it was a classic tornadic supercell in most of those cases. But a lot of times, we have warnings now that are issued they're looking for just the start of that tornado, and we're on it even before the large tornado even sets up. You're just seeing that start of that rotational echo aloft before it even sets down, and we're increasing that warning time to where, for even a strong F2 tornado, where in cases of the past, it would take a solid F4 to be on the ground, maybe in a non-populated area, before we did a good job of, hey, there is a tornado headed your way, because we kind of can verify it because it's already a very large tornado on the ground.
So when you look at where we were 50 years ago, where we are today, where do you think we'll be 50 years from now?
I think the biggest thing that's going to happen, and we're already kind of seeing with our cell phones and the warnings, is you get those alerts, at least with a tornado and a flood warning, on your phone that are automatic. And I think we're going to get a lot more of that, as that we are all so connected. I think those alerts are going to get a little better. They may be more pinpointed, and I think you're going to find more weather apps that are going to be more pinpointed to your location, and you may have more of an automatic display imagine instead of just a little alert, when you get that, if you were in the middle of nowhere, didn't know where you were, maybe you're traveling and didn't have a radar app, and all you got on your phone was, there's a tornado warning in your area, you're still kind of a little panicked, and you still kind of don't know your perspective to everything. Well, I think where we're going to start going in the future is, eventually, it may be an alert that pops up on your screen completely, and it may have, this is where you are, this is where the tornado are, and you're, through some sort of algorithm, we're telling you you're in the path, and may even, who knows, give you directions and tips on what to do.
Do you see where radar could even get better? Like we have dual pol now. Could you see all these like phased array radars, which cost quite a bit of money now? Could you see that? Could you see more radars popping up in more dead zones?
I think you can start seeing that, and we may, even start using some sort of Doppler on wheels type setup, with how well modeling is getting, I would say yesterday it was pretty broad as far as the setup, and I would say, we didn't see everywhere in that whole enhanced risk area we saw the real enhanced storms. But I think as modeling gets better, there are some situations where we're like, hey, this is the bullseye. It is definitely in this bullseye, and why wouldn't we maybe deploy some sort of Doppler on wheels as an extra radar scan, but that would be accessible more to the public, not just as a research tool, but as a way like, hey, we're going to put this in this area and it's going to help with our coverage. And I can really see that. And it may be more cost effective in some ways too. You can build another site and you keep that up, or you can maybe have an assisted Doppler on wheels relaying other information to the local radar site.
Now, I'm going to try to figure this out because I'm going to look at this more clearly. But when I'll get myself. I'm trying to get my act together.
I got about 5 more minutes, Jeff, and I gotta start prepping for my 10 o'clock news.
Yeah. So we'll conclude a little bit because there were a lot of people that died and whatnot. So we'll do our shout outs, and I'm going to shout out the monthly weather review thing that I used. That was written by Ted Fujita and some other people, and I'll throw that out there so people can look at it because there's a lot of other technical stuff in it that if we went into it, it'd be like another hour and a half. So, Tom, if you want to shout out anything, your report that you did for your newscast, whatnot.
Yeah, the report's actually going to air tonight. It's going to you can go to abc57.com, and the report will be on there. And really, it's kind of what we talked about at the top of this broadcast is that we've seen nothing close to this here in Michiana, in my region, before or since. 5 long-track large tornadoes. And that's what I find most amazing about the event here. And that's what I talk about in the write-up, and there's some good graphics to go along with it. abc57.com. And with that, there'll be a link and information for tomorrow being the 50th anniversary. Our local weather service office at NWS IWX will be live tweeting the events tomorrow as well. So they're going to be kind of doing a social media aspect of the events that led up to Palm Sunday and the actual storm and tornado reports. And they're using let me make sure I get this up here and have it right. They're using the hashtag Palm Sunday 50. Let's see. Yes, Palm Sunday 50 is the hashtag. You can follow along with that.
Yeah, so now we'll ask how anybody can get a hold of you normally.
I'm on Twitter, and that is probably the best way. I am on Twitter all the time. I feel like I'm almost always connected with it. At Tom Coombs, it's just my name. On Twitter, you get me there, and I can relay you my email address. And, of course, there's all that information on abc57.com as well. But at Tom Coombs on Twitter, I think that's probably my biggest use of social media. I do Facebook for my job. I do Twitter for my job, and just anything else. I think I have the biggest connection. And, Jeff, that's, in fact, how you found me, was on Twitter.
Well, actually, I found you because I saw your coverage from a year or so ago.
Well, yeah, but then you contacted me via Twitter.
Yes.
So.
But anyway, so I'll let you go, and I'll wrap up the show for those that want to hear about what's coming up in the next couple of weeks. So thank you, Tom, for spending a little over an hour with us.
I appreciate it anytime.
Okay, thank you.
Thank you.
So as Tom begins to depart, we're going to talk about who's going to be on in the coming weeks. Next week, we're going to be talking. Today we talked about tornadoes and a big event. Oh, you're going to want to be around for next Friday. Dave Nussbaum from WWL in New Orleans is going to talk about Hurricane Katrina. 10-year anniversary of that is this August, so we're going to have him on. Fred Gossage is going to be on from WBRC in Birmingham on a Thursday, April 23rd. We'll probably talk about April 27th again. We've talked about that event several times. Eric Wilhelm from WFMJ in Youngstown, Ohio will be on May 1st. We'll talk about the 30th anniversary of the tornado outbreak that occurred in Ohio and Pennsylvania, which also included an F5. John Wetter is going to be back on again. He's with the HOP WRF. He's going to talk about outbreak that occurred 50 years ago in May, which was the Twin Cities outbreak in 1965, which was the first outbreak where watches and warnings were used, which we described or talked about earlier. Jeff Baskin from KLRT in Little Rock will be on May 15th. And we have other guests that we're trying to line up for the end of May and into early June. So if you want to get a hold of me, I'm on Twitter at IowaWX. That's IOWAWX. You can get a hold of me via email at iowawx@gmail.com. Our other co-host, Henry, who's not on tonight, you can find him on Twitter at henrycluker_WX. And his email, I don't remember offhand, but he'll probably yell at me for not telling that. Mike, who's down in Tennessee doing probably a baseball game right now. You can find him on Twitter at WXMC. That's known as Weather, WX, M for his first name Mike, and C for his last name Cox. And he may come back. We're not sure when he's coming back. So thanks, everybody, for watching this week. Hope you'll join us again next Friday when we'll be talking, hopefully, with Dave Nussbaum from WWL in New Orleans. Thanks, everybody. Have a great weekend. Have a good week, and God bless.